We are Team GIC Cyber. Our focus is on integrating agentic workflows and solutions to strengthen our organization's cybersecurity efforts. Today, our rapid threat assessment process takes up a significant amount of analyst time. A lot of manual research is required to identify relevant threats in the wild that could affect our assets. There is also a risk of human error when contacting the correct officer in charge to escalate identified threats and CVEs. Another pain point is that many of our systems are fragmented. They do not interact with one another effectively, which makes it difficult to generate meaningful insights. Our goal is to add an agentic layer that augments the analyst workflow and improves productivity. We want agents to do the heavy lifting for web crawling and threat research. We want to link systems together to create a holistic view of our current threat exposure. We want to build a data pipeline that refines data from bronze to silver and finally to gold. And we want a human in the loop for the final step of correctly contacting the affected officer in charge. Our agentic workflow is built using LangGraph, using databricks GPT 5.4 gateway endpoints. The supervisor agent is loaded with previous research as part of its context. Based on that past research, the supervisor can identify topics that do not need further investigation, which helps save tokens. It then spawns sub-agents, each with its own context, to perform web searches on assigned topics using the AXA API. These sub-agents run asynchronously, so research tasks can be completed in parallel. Each sub-agent returns its findings to an orchestration agent, which validates the accuracy of the research, such as checking the correct CVE references and dates. The orchestration agent then stores the validated research in the relevant tables and generates a report. This also acts as a memory layer for the supervisor agent. For observability and monitoring, we log every API call, each agent's reasoning, and the tools being used. Every agent has an agent ID, and each handoff between agents is also tracked. To enforce guardrails, each agent is given restricted access based only on its assigned task. This process runs in the RTA, Researcher Notebook, which is scheduled to run at 8-hour intervals. In a separate process, fragmented data is aggregated into a single table through API calls in assets data ingest.py. The final process is the RTA, Report Notebook. An analyst can run this notebook to generate a dashboard view of the latest threat research report. The generated report is also fed into a chat agent, allowing the analyst to interact with it and explore the report further. Here, we can see the different tables used in the project. All of the data is synthetic and was generated to model our internal data. Next, we can see the jobs that are running as part of our data refinement pipeline. Lastly, we have the report dashboard, where an analyst can pull the latest research and apply filters. The report shows the number of vulnerabilities found, their severity levels, the associated threat actors, and the affected assets. Within the report, an analyst can chat with the agent to draft an email. There are 2 affected officers. The correct officer in charge is identified in the draft, based on the associated threat. From this demonstration, we can see the benefits of using Databricks as a platform to house our data, transform it, and generate insights that help us achieve our intended goals. Thank you.